Dear students, in this video on physical word and measurements, we will study about significant figures with examples. So let us begin with the idea of significant figures. And the word significant literally means important. So let us take an example. We have a line segment AB which we are measuring using this normal ruler. So one end is kept at 0 centimeter and you can see that the other end lies between 6 centimeter and 7 centimeter, and this 1 centimeter is divided in 10 parts. So each part is equal to 0.1 centimeter, right? And if you look at this point B, then it lies somewhere between 6.2 centimeter and 6.3 centimeter. You can have it, look at it. So the first digit 6 is sure. It is called reliable digit. I am sure about the first digit. Now the second digit, whether it is 6.2 or 6.3, the second digit is not reliable. And if it is not reliable, so as I said, that the length can be anything like 6.23, 24, 29, whatever. Say 6.27. So if I am not sure about this digit 2, I cannot be sure about the next digits. So they will also be not reliable. Like if it is this one is not reliable, then the following places after decimal will also be not reliable. Okay. So let us look at one more example. Now here another line segment AB is being measured with a ruler having smaller least count. So one end is kept at 0 and here you can see that 1 centimeter is divided in 20 parts. So that means each part or each division is 0.05 centimeter. Each point is half of millimeter or 0.5 millimeter, half of millimeter, right? Now if you look at this, the other end B, then it is lying somewhere between 3.1, 3.2, 3.25 and 3.30 centimeter. 3.25 centimeter and 3.30 centimeter. So I am sure about this 3 and this 2 also, but this 0.5 is doubtful. And from here it is clear that the length of the line is somewhere between these two numbers. So it can be say 3.27 or 3.29 or anything, right? So the last digits are always not reliable in a measurement. Last digit is always not reliable, but the initial digits like 3.2 here, 3.2 here, the initial digits are reliable. So let's see how we define significant figures. So in a measurement, all the reliable digits along with the first unreliable digit are called significant figures. You can have a look. See? All the reliable digits along with the first unreliable digit are called significant figures. So now we will learn the rules for determining significant figures. We have some rules for them. So let us begin with the first rule. All the non-zero digits are significant and all the zeros between two non-zero digits are significant irrespective of the position of decimal point. So for example, if I have this number 201405, then you can see that we have non-zero digits 2, 1, 4, 5 and zeros lying between them. So they all are significant and this number has 6 significant figures. And now I have chosen a decimal number. So 204.03, and here you can see that 2, 4 and 3 are non-zero and zeros are lying between these non-zero numbers. So all are significant and this number has 5 significant figures. Now, the trailing zeros in a number without decimal point are not significant. That means if we have a non-decimal number like this 201400, then ये जो end में zero आ रहे हैं they are called trailing zeros and these trailing zeros are not significant, whereas this zero in red is significant. So this number has 4 significant figures. You can see that here 2014, they are significant and the zeros which are coming at the end, they are called trailing zeros and they are not significant. So this number has 4 significant figures. And now the next rule. If the number is less than 1, that means it is a decimal number. The zeros on the right side of decimal point but to the left of first non-zero digit are not significant, and the trailing zeros in a number with decimal point are significant. So let me take this example here. We have this decimal and the first non-zero number is 1. So the zeros between decimal and first non-zero number are not significant, and the zeros which are coming between non-zeros are significant, and here the trailing zeros are significant. So this 1040, this number is significant and these zeros are not significant. So the number has 4 significant figures. Okay. And now the numbers coming from exact countings, exact numbers, they have infinite significant figures and constants like pi and exponential e also. Like if I say that I have 2 books, then it is number 2 only. It cannot be 2.2 or 1.9. So 2 books, when I say, it is an exact number. Similarly, if I talk about 50 rupees, then it is exactly 50 rupees. It is not 49.9 rupees or it is not 50.1 rupees. So these are exact numbers and they have infinite significant figures. And then we have some constants like pi, and you know that pi is 3.1415 and so on. It's a non-terminating decimal. So this also has infinite number. Similarly, the exponential e also has infinite number. Now, another very important rule, the trailing zeros coming from actual measurement are significant. Means what? Supposing we have a line segment of length 20 centimeter, is 20 millimeter, 20 millimeter. That means it has been measured by using a ruler which has least count of 1 millimeter, right? And so the length is 20 centimeter. Now if we look at the previous rule, this number 20 has one significant figure because the trailing zero is not significant. But here in this case, this zero is coming from actual measurement. So this is also important or significant. So this 20 millimeter has two significant figures. So these are some rules to find out significant figures and very important rules. And now, rounding off of uncertain digits. So rounding off of a number means dropping off digits which are not significant, and you are familiar with some of the rules, so let me just tell you that if the digit to be dropped are greater than 5, then add 1 to the preceding significant figure. Here, if I have 2.346 and I wish to drop this 6. Now the 6 is greater than 1, so we add 1 to the previous number, 4. So the result becomes 2.35 rounded off to 2 places of decimal. So you already know this rule. Another rule, if the digit to be dropped is less than 5, then it is dropped without bringing any change in the preceding significant figure. That means if we have a number like this and I want to drop this 3, which is less than 5, so I don't make any change in this number 4 and just drop 3. So the result is 2.34 rounded off to 2 places of decimal. So what if the number to be dropped is exactly 5? So here, if the digit to be dropped is 5, then the preceding digit will be left unchanged if it is even, and it will be increased by 1 if it is odd. So look at an example first. Here, in this number, I want to drop this 5 and the preceding digit is 4, which is an even number. So the result will be 2.34. And in this case, I have to drop this 5 and the preceding digit is odd number 3. So we increase it by 1. So I get result as 2.34. Right. So when we have to drop 5, my resulting number will always be an even number. Like here I have 4. Here also I have 4 only. So I hope this rule is clear to you. And now, significant figure in addition and subtraction. So let us look at the example of a simple addition. I have a number 2.75. It has 2 decimal places and 3 significant figures. Next number 1.5077, 4 decimal places, 5 significant figures. And then we have 12.244, where decimal places are 3 and significant figures are 5. Right? And I have shown all the digits in red as unreliable. You see, significant figure is all the reliable figures plus 1 plus 1 non-reliable. So this 1507 are reliable, 7 is not reliable. This 1, 2, 2, 4 are reliable and 4 is not reliable. Okay. Now simple addition. When you add, this 7 comes as it is, not reliable. Then when you add 7 and 4, you know that 7 is reliable. आप 7 के बारे में श्योर हैं, but 4 is not reliable. So इन दोनों का जो sum है वो भी not reliable होगा. And 7 plus 4 is 11. So this one is not reliable, and take 1 as carry and you get 6 plus 4 10. Now here this 5 is not reliable, so the sum of not reliable and reliable will be not reliable. So you get 0, and from here again you get 1 carry, and when you add, then you get 15, and 15, say you write 5 here, and look at it here, this 7, 5, 2 all are reliable, so the sum is also reliable. And then you carry 1 here, and then you get 6 and 16. So the result is 16.5017. And now you know that a number is written with all significant figures, all reliable figures plus first unreliable figure. So 16.5, these are reliable, and first unreliable is 1. So the result is 16.50, and it has 2 decimal places. And if you look at these numbers, then the number with least decimal places, the first one, 2, and the result also has 2 only. So in sum and difference, in addition and subtraction, the result will have number of decimal places equal to the number having least number of decimal places. So here, in addition and subtraction, the final result should retain as many decimal places as are there in the number with least decimal places. A very interesting outcome of this addition and subtraction is here. The subtraction of nearly equal quantities destroy accuracy. So दो क्वांटिटीज़ जो बहुत क्लोज हैं तो उनका डिफरेंस जो है एक्यूरेसी ख़त्म कर देगा. लेट्स सी हाउ. If I take the example of 2.034 minus 2.032, so you see that 2.03 reliable, 4 is unreliable. 2.03 reliable, 2 is unreliable. And the difference is 0.002. Now 4 is unreliable, 2 is unreliable. So 4 minus 2 will be unreliable. And you know that the zeros between decimal and first non-zero are also not reliable. So all these terms here all the digits are not reliable. Here the result has unreliable digits only. So that means the accuracy is destroyed. Very interesting outcome. And now let us look at the significant figures in multiplication and division. So a very simple example of multiplication here. You can see we are multiplying 2.45, it has 3 significant figures, by 1.5 which has 2 significant figures, and the last digits are not reliable. I have shown them in red. So see, when you multiply by 5, then 5 is unreliable, and when you multiply by 5, you see 5 multiplied to 5, unreliable, unreliable, you will get unreliable. 5 multiplying 4, unreliable multiplying reliable will give you not reliable. Then 5 multiplying 2, you will get not reliable, and you are getting 4 places here. So the last one will be reliable. Okay. So we get these 3 digits as not reliable and 1 as reliable. Now when you multiply by 1, you leave 1 place here. When you multiply 1 to 5, this will be not reliable. But when you multiply 1 to 4 and to 2, then you get reliable digits. And when you add them, then 5 not reliable, 2 plus 5 7, again not reliable. Now 2 is not reliable, 4 is reliable, their sum will be not reliable, 6, and then you add 1 plus 2, they both are reliable, so sum is also reliable. And Look at it. I am getting and here this has total 3 decimal places. So here we will have 3 decimal places. So 3.675. And now I have to keep 1 decimal place only because 3 is reliable and I will keep only 1 unreliable place. And if you look at it, I have to drop this 7. And 7 is greater than 5. So I will do rounding off and add 1 to this 6. So now my result is going to be 3.7. Now this number has 2 significant figures. And when you look at this one, the number with smaller number of significant figures is this one, which is 2 only. So product cannot have more significant figures than this one. So let us look at the rule. In multiplication and division, the final result should retain as many significant figures as there are in the original number with least significant figures. So this is applicable to both multiplication and division. And let us look at scientific notation. Now, to avoid any kind of confusion, we must report all the results in scientific notation. So, in scientific notation, a number is expressed as a into 10 raised to the power b, where this a lies between 1 and 10. Look at it. 1 is less than or equal to a is less than 10. And this a contains all the significant figures. A contains all the significant figures and b is an integer. It can be positive, it can be negative. For example, if I have 2.05 into 10 raised to the power 3 meter, then this a, look at it, it lies between 1 and 10. It has 3 significant figures. So the measurement has 3 significant figures. If you look at another example, say 1.235 into 10 raised to the power minus 2, then this number lies between 1 and 10 and it has 4 significant figures. And a choice of change of unit does not change the number of significant figures in a measurement. That means if we change the unit, like converting meter to centimeter, millimeter or anything like that, then the number of significant figures must not change. So let us look at some examples here. See, if I take this example only, 2.05 into 10 raised to the power 3 meter, then if it is converted to millimeter, you can write 2.05 into 10 to the power 6 millimeter. And if you want to convert it to kilometer, you can write it as 2.05. See, kilo is 10 to the power 3 kilometer and I can write it as 10 to the power 0 also. So, you see, in each case, the number of significant figures are 3 only. We have changed the unit from meter to millimeter and kilometer, but number of significant figures remain the same. Let us look at one more example. 1.235 into 10 raised to the power 2 meter. Now you know that 10 to the power minus 2 is centi. So you get 1.235 centimeter. And we can convert it to a millimeter also. And to convert centimeter into millimeter, we have to multiply by 10. So 1.235 into 10, that is 10 to the power 1 millimeter. So each one has 4 significant figures. So we must remember that while writing any number, say the first digit, the first a should be equal to like whatever 1.245 into 10 to the power whatever. Here The decimal place should be after first digit. And we must report all the results in significant figures only. So let us look at some numerical problems here. The sides of a rectangle are measured to be 25 centimeter and 45 centimeter. Calculate the area to appropriate significant figures. See. Now, the number of significant figures in 25 centimeter and 45 centimeter are 2 each. Area is length into breadth. So 25 into 45 gives you 1125. And this is showing me 4 figures. But according to the multiplication rule, the result cannot have more than 2 significant figures. Because see, 25 and 45 both have 2 significant figures. So here these last 2 digits will be changed into 0 and the area will be 1100 square centimeter. Correct to significant figures. And let us take an example of addition here. A box of mass 5.245 kilogram contains 2 small objects of masses 22.0 gram and 2.2 gram. Find the total mass of the box along with the objects. So first thing, we should convert them to same unit. So the sum is mass of the box plus the first object 22.0 gram, that will be 0.0220 kilogram. Second object 2.2 gram, so 0.0022 kilogram, and when you add them you get 5.2692 kilogram. Now according to addition rule, the result should contain decimal places equal to the least number. So this has 3 decimal places, this has 4 decimal places, this also has 4 decimal places. So result should have minimum number of decimal places, that means 3 places. So from here the result will be 5.269 kilogram. And one more example here. The diameter of a sphere is measured to be 12 centimeter. Calculate its surface area and volume. The mass of the sphere is 125.00 gram. Calculate its density. So, what is given is diameter 12.0 centimeter, which has 3 significant figures, and the surface area of a sphere is 4 pi r square. So I can write it as 4 pi, and r is d by 2, and when you simplify you get pi d square. So pi here and d square is 12.0 into 12.0, and this, as I told you, exact numbers and constants have infinite significant figure. So 4 pi has infinite significant figure, so we do not have to worry about it. And when you multiply it, the product comes out to be 452.16 square centimeter. But the number of significant figures here are 3 each in product. So the result can have only 3 significant figures. So that means these 2 have to be dropped, and surface area can have only 3 significant figures. So S is 452 square centimeter, and in scientific notation it will be 4.52 into 10 to the power 2 square centimeter. Similarly, we can find out the volume also. Now volume is 4 upon 3 pi r cube. So 4 upon 3 r is d by 2 whole cube, and when you simplify it, here you will get d cube upon 8, and that means you will get pi upon 6 d cube. Put the value of d, and diameter is given to be 12 centimeter. So simplify it, you get v is equal to 904.32 cubic centimeter. But since d has only 3 significant figures, so this multiplication can have only 3 significant figures. So volume will be 904 cubic centimeter, or 9.04 into 10 to the power 2 cubic centimeter in scientific notation. This is scientific notation. And now let us come to density. Now the formula of density is mass upon volume. So the mass is given to be 125.00 gram, and convert it to kilogram SI units. So into 10 to the power minus 3 kilogram, and volume is 904 cubic centimeter. So 904 into 10 to the power minus 6 cubic meter. Convert this cubic centimeter to cubic meter, and look at it. See, 1 cubic centimeter is equal to 1 into 10 to the power minus 2. See, centi means 10 to the power minus 2 cubic centimeter, and this whole cube. I'll write it once again. This cubic centimeter is 10 to the power minus 2 meter, and this whole cube. Centi means 10 to the power minus 2, and from here, see, power over power multiplies, and you will get 10 to the power minus 6. That is what I am using here, 10 to the power minus 6 cubic meter. And simplifying it, you get 0.138 into 10 to the power 3 kilogram per cubic meter. SI unit of density is kilogram per cubic meter, and it should have 3 significant figures. So in 3 significant figures and in scientific notation, this becomes 1.38 into 10 to the power 2 kilogram per cubic meter. So with this, I come to the end of this topic. I hope it is you have understood and it is beneficial to you all. Thank you for watching this.